Now, you're going to do this first. This folder, here you can see, this is for your driver 8835. That's the driver that is on your board. You understand? Clear? Okay. So now, this is a simple one, but I shouldn't have put that, but okay. So this is the code that is there for an L298 motor, okay? So this, I'm just explaining you what your homework is, okay? So if you have any questions, let me know, okay? So this one is an L298, okay? So this is connected to, that's my motor 1, this is my motor 2. So whatever this is left motor, that's the right motor, you understand? Now this guy has three pins like that. You understand? So this is going to your microcontroller. So this three pins, this is for the left, this is for the right. So if I take the left motor, so here you can see it has enable left, in one left, and it has in two left. Okay? So this is where you give the PWM, and this one 0 0 means it doesn't run. 0 1 it's going forward, 1 0 is going reverse, 1 1 it's braking. You understand? So that's the code for it. And that's how this is written. You guys understand? This is written for this particular specification. Clear? Is everybody understanding? So this is run. So that's why you have 9, 10, 11, 8, 12, 13. These are the Arduino pins, correct? So these are the Arduino pins. You can see it is going to say you have to put in what is the wheel diameter radius. Clear? So you're going to put in the value, what is your wheel separation, diameter, and then you see, oh, you just have to change this. Okay, don't worry about low speed, high speed. You can put 450, right? You can go up to 400. Leave it again, command velocity. So this is what it is. In the loop, this guy is simply going to go, that is initialization. And now what it's going to do is it's going to go through certain high, you're not going to go left, right, it's going to go by itself. You're not going to do, so all it's going to do is, this is the code, right? And then you can see, this guy, most importantly, is also going to publish. This is going to not publish, it's actually going to subscribe for command velocity. It's going to ask for the ROS to supply it with a message called command velocity. Okay? So therefore, when ROS gives that command velocity message, this guy is going to rotate either left or right, or go straight, down. You understand? Okay. So you're not using this driver. You are actually using U32U4, and in this case, you only have two of them. You're using DRB 8835 or 8, I don't know, whatever it is you guys do. Okay, but it's the same. So here you only will have two. That's why I've just given this code. This is without the ROS. You only have what is called as an enable left, and then you have direction left. You have enable right, and you have direction right. You understand? You only have that. So there is only direction. So therefore, enable X is equivalent to PWM. That's where you get the speed. So in this case, what will happen is you will have enable X is your PWM, and then when you give direction left, when you give 0, it goes forward. When you give 1, it goes reverse, or whatever it is. Understood? So this direction is only this control, 0, 1, simply controls going forward, backward. That's it. Yes. So what is required by you is this is your pin. This is exactly the pin. You don't have to worry about it, but you have to set it. You have to copy this. That's connected to 10. PWM comes from 10. This comes from 16. This comes from 9. This is 15. This is for your board, ROMI board. Okay? So I change this, and now this is set up, but this one simply says just go at one speed. So what you're going to do is you're going to get this one, change this code for this driver. That's it. You understand what I'm saying? you're going to change this code to this driver, and then you are going to run ROS code, then you're going to do ROS, what else you want to do? Yeah, ROS run, and you're going to run, what would you run? Obviously you're going to compile this, put it in your Arduino, and you're going to do a ROS run, and then you're going to say publish, and what is the other one? You are going to say something like, the topic would be command velocity, and you're going to say left and right values. So it's going to go either straight, or if you give same values 1, 1, it's going to go 2, 1, it's going to go left. You understand? Clear? Yes? Okay. So you guys understand, right? So hopefully make sure that the blink LED is working. No?
Oh yeah, on Windows, yeah.
No. Why you compile it on Windows?
Yeah.
Then take it back.
Oh.
Did you take it back?
Yeah.
After that you don't
Yeah.
need it. Did you take it back?
Oh, okay. Yeah.
Yeah, you can take it back, and then because after that you don't need the TTY ACM0. You don't need it.
Oh, okay.
You only need that USB. That USB will always show up no matter what it is, because that's with the FTDI. That's already had a signed one. That you don't need anything for the USB to recognize. I mean the Linux to recognize. You understand?
Mm-hmm.
The red chip that I gave you, right? It doesn't need any driver, nothing. It's so universal, so it just will accept any, on any system. Okay? So you don't need it to be recognized. You only need the USB to recognize, and then you type the thing. Okay. So that's the first task, right? The second task is, as you can see over here, I have a code which basically takes an MPU 6050 data. So if you guys have that chip, it's okay. If you don't have that chip, I'll try to get it to you. Maybe in the end of the class you can ask, but if you're in 403, it's part of your kit. If you're in 301, it's part of your kit.
Wait, what is?
The MPU 6050.
Okay.
So this code is for MPU 6050. You understand? If you guys don't have it, I will give it to you at the end of this class. If you are part of 301 or 403, that's part of your kit. Yeah. Okay? So it's part of the kit. So what you're going to do is you're going to connect it in your I2C pin. Okay? So similarly go here and then figure out where your I2C port is. That is here. You can see that's your port. I can zoom in. There you go. That's PD1 and PD0 is your I2C port, right? So connect it. So that's also, remember that this has two boards, okay? That driver has two boards. One is the Arduino compatible board, and the other one is the Raspberry Pi compatible. You understand? So this guy here, all this is Arduino compatible. When you go over here, that's Raspberry. That's Raspberry. Over here, still Arduino. So you have multiple, that's very versatile. Okay? Okay, so you are going to first push this, correct? So here you can see that this guy is going to actually, same thing, it's a publisher subscriber. So here you're going to get this data, and you can see it's going to talk to I2C and send the data through ROS serial. So now, once you say echo, get me, so let me show you one more thing. Okay, so the other way to do it is, I'm going to still disconnected it. So I had a couple of examples, so I'm going to show you a couple of examples, okay? So I'm going to run, okay, this is a publisher and subscriber, right? So this is quite interesting. What it is, the Arduino board also subscribes to the LED toggle, and also is a publisher. Do you understand? So it's also publisher. But in this case, being a simple project, we are simply telling it to do a chatter, that is the topic. And here, we're going to say, hello world, exclamation, okay, what else? Okay, just, then, it's going to actually, okay, done saving, okay. So now, let me click on this. I have it there, I have it there. Okay, everything is good. I hit okay. So it's actually uploading it. Okay, so now let me run. So you have to run Roscoe, right? So now to run this program, what should be my command? That's the question. Right now, at least you should have figured out what the command should be. You know, just ROS run. What else should I do? I can't just do ROS run. What should I do? Yeah. Package name followed by the node. So what am I trying to do now? Are you guys listening or not? So what am I trying to do? Take data from where? From the board. Through what? Serial port. So therefore, when I'm going to do everything that you do with an Arduino, remember this, you're always going to do ROS run, and you're always going to put ROS serial. You understand? Because ROS serial, and then you're going to always use the Python script. So that's going to be a package, ROS serial Python. Clear? And what is the node? There's only two nodes that is offered by it. When I do tab, so you can see, it'll just say one is an info service. You're not running a service. You are actually running a node, right? So that's the other thing is called serial node. And obviously, I have to say which port it is because now I have multiple ports. So I have to put port equal to, I have to put dev, TTY, USB 0, correct? Understood? Because that's what I have to listen to. And I don't really need to say what my baud rate is because it's like by default, right? Whatever it spits out, this guy is going to. That's the good part about Python, right? You don't really need to say, listen to this particular baud rate. By default, that guy spits at 57,600. By default, this guy listens at 57,600. So everybody's okay. So once I hit it, so now you see that it's going to connect. And now that's the more important thing. It should say it's subscribed for it, and it's saying I'm looking. I actually have two things. I have a publisher that is called Chatter. It's a message. It's a standard message which is of type string. Okay. So if you're wondering what are the different types of messages that are supported by standard, so you can always put ROS message and you can say list, then you can put, I think that's the one, yeah. So these are all the different standard messages, but if you want to do standard message, yeah, let's see. I have a cheat. I need to get a cheat sheet printed, otherwise I have to go back and forth and keep referring to. Okay, not the list, so I have to show.
I wonder.
Okay, so you can see that when you type in like messages, see, you can have like a sequence. Those are the fixed ones because when you do standard messages, these are fixed ones. So that's the sequence number, timestamp, and then there is this frame ID. So these are the standard ones. So that's the message. But what it is showing here is that this particular thing here is of type of standard message, not the header. The header information is that. Plus, it gives you another value which is string. You understand? So in any data that I pull out, I will get this 3 plus that 1. That's what it means. Okay? And then over here, it's looking for it. So now, let's say I don't want to do another thing, but I just want to list it. You can always do ROS, and then you can say topic, and you can always use the word like echo, and then you want to do the echo for Chatter. You see? That's my topic. You understand? So if I hit this, it's going to actually keep giving you, why is it binary? What happened to the binary? It should actually give you. So it's actually trying to type in, maybe it didn't like the many exclamation marks because the value went above. That's done updating. I'm going to rerun that. Thank you. So you know the value was more than 13, so the exclamation mark it just got totally corrupted. So that's why it messed it up. Okay. So now this is basically, you can also use the echo command. You understand? So I can also now, you can run the one, which is basically, I don't know, we ran it some time ago, which is the toggle one. Where it was that. Okay, so basically you can toggle it now. So it also splits this one. So this is actually what it's transmitting. Yeah? And then you can use this topic, run rvis, and you can actually display it. You guys get it? Or I can use it and bag it. I can collect the data. So you guys understand? Slowly you understand that ROS makes it very easy just by doing all these things. Great. So here, this is just the character that it's actually sending, right? This is just the label, and then this is the message. So if I'm actually getting a value, you can push in the value. So now you can actually push in the accelerometer value, gyro value, and then you can have ROS collected everything. If you're capturing an image, you can capture that image and then give it to ROS, right? And he can store it. Simply he can store it. Then he can take that value, and then if you have an accelerometer value, then you have an image and you want to do some corrections, you can do corrections because they're all synchronized. You use a topic to do it. Okay? So most importantly, when we go and we keep on adding packages, you will see that they will give you a package, right? So when they give you the package, all you're going to do is drag that package down to your source file and do captain make. That's it. And then all you have to do is type in something like this. ROS run, name of the package is lidar XYZ, and then say whatever you want to do with the Python script. That Python script would automatically pull up and show you all the visualization. End of story. That's it. As easy as that. You guys understand? So the idea is, what I'm trying to tell you is, like, if you try, you know the basics, how to use it, then everything using it becomes easy. Obviously developing is difficult. You understand? But 90% of the work is done by just using ROS, not developing anything in ROS. That's 10% of the people who actually develop it. You understand? So those are the guys who manufacture the stuff. It's not our job. Our job is to just plug and play, put it together and make it to work. You understand? All we are doing is only probably 5 to 10% programming. We take that, we take the Python script, and we modify the Python script. So instead of storing it into the SD card, it just decides and then moves the model left or right. That's all you're going to do. So the concept is you don't reinvent the wheel. Okay? Alright, so always remember that whenever you do it, right, the ROS run, you have the package, and then I can also list the topics. See here, I can also do list topic or a ROS topic. I can list it. So that's the topics, you see? So what it is when you list the topic, you will figure out, oh, what does it say? What is it having? Oh, chatter. What is a chatter? Oh, that's actually a publisher coming from the Arduino. What is a toggle LED? That's actually a subscriber to the thing. You understand? And so that's what it is. All here is the ROS is not doing. The Python script is simply reading the data. Okay? You can also, there's also something which is called if you want to develop a pure C code, there is also something which is called the ROS serial CPP, which will, open up the serial code and then try to display. You understand? But usually a lot of people just, because we are only capturing data, seeing data, so that's why we usually use the Python. Because, you know, we are using the Python. Okay. So you can actually, once that is working, you can run with many of these tools. Go to examples, and you can see that we have so many of these tools. So that's odometry, right? Whatever you get. So you will see that's a left and right. So that's what it gets published, and you will see left and right. So that will be our next goal, is to take those odometry and then send it to this guy. So the message will have L and R. So you have two values, integers for left and right. So it keeps on producing left and right. You understand? So for the next thing, that's why you basically go from here and you go to customize messages. Correct? How to do customized messages, because then in your case is your odometry is only left and right, and then you want on top of it you want to actually add the heading angle, then you add the heading angle, so you know how speed you're going and which direction you're going. Get it? Understood? Okay. So now, and then that's the one you can see. This is also good infrared ranger. That's an IR. That's an ultrasonic. So in case you guys want to actually do this, I can actually get you the stuff too. I have, you know, I'll just pull it up from the lab and I'll give you. So you guys can do the infrared. I'll give you an IR sensor. I'll get you the ultrasonic. So you guys can test it out and see if it's working. You understand? That's a simple thing. You take it, it sends it to the ROS. ROS says, if you're too close, it'll say stop command will be given. That's how you do autonomous. You understand? But obviously, if you don't want to, you can do that, but you know, you want to do it much more better, right? I don't think the button ADC, I've tested almost everything. I almost gave up, and then I tried to do it with TYC. I finished TYC, felt good, and then I came back and it was okay. That took 1.5 days. So yeah, I did it with Arduino. I did it with TYC. Everything worked except this. So then I said, okay, let's ask the guys to buy a new board. Okay, so anyway, so coming back to this is IMU data. So if you don't have this, I'm going to get you this, you're going to do this. And I think I also did this, but I don't have my board with me now. I did this one, and it'll actually print out data. All I did is I just ran this, and then I typed in echo, and I put in the values. It's going to give you all accelerometer and drive. So, but one other thing, you guys do not have this board, or this is not what you have. If you actually go into this, into Pololu, over here, not this one, your control board. So here you're going to see that's your DRB. So that's, see, this is where you picked up. That's one is connected to D16, other one is D10. Here, D15, and this is D9. So this is the phase one. Phase controls the direction. Enable is the PWM. Okay? So that's where we picked it up from. Let me show you where your board is. Okay, so this is your that's your accelerometer. You understand? So you are going to change it into DM6. You get it? Correct? You guys understand? That's your accelerometer. That's on the board. It's connected to I2C. So where do we start? So you go to Arduino. First go to Tools. Go to Manage Libraries. And first and foremost, before you go, obviously you have the board, so you should be okay. Just type in LM. What was the name of it? LM, LSM. There you go. Once you type in LSM, that's going to come up. All your drivers are going to come up. You understand? And where is ours? Yeah, I guess this is LM6 DS33, right? So I guess that's basically what it is. You should be okay with that guy. Just do an install. Okay. Yeah, this is another one from Seed Studio. Yeah, but I'll just go with the general Arduino library install. Correct. So now what it is simply you don't have to worry about what you have. Just download. So once I've done this, go OK, go to File, go to Examples, and then go into this Arduino. No, that's the D. That is the 6 simple accelerometer. Click on this, download this into your board, and read the values through the serial port. At least you know the pin, you handle the board quite roughly. At least now you know it's working or not. You're getting the accelerometer. Then you're going to do the same thing for the gyro. You're going to read this value. Now you're going to cut and paste this guy into the code that is provided, which is here. There's the code that's provided. This is the code, sorry, IMU data code, except that over here, you're going to include that library. You understand? You're going to include this library. You're going to almost keep this, most of these guys, you're going to change. Once you include the library, you're going to take away all these things, but keep, wherever you see ROS, keep it there. You understand? You're going to, whatever you see ROS, you're going to keep it. You're going to get rid of the rest of it. Serial begin, keep it. But this one doesn't even use the library, you understand? It only uses the basic library, which is called wire, which is an I2C library. So you're going to keep all this, and you're going to publish, and you're going to publish it through ROS. You guys get it? You seem to be shaking. I'm surprised too, but you seem to be understanding everything. So you understand what needs to be done? Yes? So you're going to change that to that. So first you're going to make sure that you're working on the MQ6050, get the data, make sure everything's okay. Then change it to this LSD3M, whatever it is. Clear?
Yeah.
And you're going to get the data. For third task, you're going to install Arduino, you're going to install ROS onto your Raspberry Pi, and then you're going to repeat the same step. Got it? So you just for the ROS, simply go to this, that ubiquity. Yeah, just hit that, and then you can see you have your Raspberry Pi images. So click anything, doesn't matter. Probably later on we'll cut the head off. So we're not going to run it with the GUI. So this is the LXDE is with the GUI. Okay. So for now you can run it. So take one of these guys and then simply push it into. So it says here, just simply push it into the Raspberry Pi. Take the Raspberry Pi, slap it on the back. You will not be able to communicate with it. Okay. Reason is, what it is this guy doesn't have a serial. This serial and that serial do not get connected. You understand? So what you will need to do is, you guys understand what I mean? Because the serial ports are not connected. Because technically serial 0 is connected to the Raspberry Pi. The same problem. Serial 1 is not connected. So therefore, what you're going to do, that's why I told you to solder the pins in the first place. That's the reason why we wanted to solder them. So what you're going to do is you're going to run 2 wires from here, which is PD this, to this point here, because that's the Raspberry end of it, this is the Arduino end of it. You're going to manually run those wires because of the serial 1. You understand? That's the reason, otherwise we don't need to actually have those pins. But there's another way of doing it. Instead of using ROS serial, there is something which is called ROS I2C. You can communicate with I2C. But the problem is, if you're getting anything, a code, you will find there's only 1% code which uses ROS I2C compared to 99% of the code that uses ROS serial. You understand what I'm saying? Okay? So these guys, if you really look at it, this device itself, the Raspberry Pi, and this board actually communicates using I2C. But they use a Python script. They don't use ROS. So this board, in this Pololu, they've never done it with ROS. That's why they didn't think through the ROS serial. You understand what I'm saying? Okay, so what I meant is, if you go through this, go back, and so that's the library. See, that's the library for the accelerometer and the gyro. Let me see. Oh, see? So it says Raspberry Pi interfaces. So they have, so the other reason is you need to run it, there's this on the top, I don't know where my stuff is, anyhow. If you see on the top, there's a little bit of cluster of little bit small tiny ICs. Those are actually level shifting ICs. You understand? Can you see? No? Okay, let me show you the diagram or the schematics. Over here, that cluster is level shifting. Why? Because this Arduino runs at 5 volts. You understand? This runs at 5 volts, and the Raspberry Pi runs at 3.3 volts. So, generally, there are, when this is connected through this, all these small level shifters take care of it. But if you're bringing something from outside, then you have to route it through those guys. You understand what I'm saying? So whenever some of these pins are already connected here, and they already will run through that level shifters. But if you're bringing something from outside, you have to run through this level shifters. That's why you have 2 pins. This is in and out. Whatever you bring it in, this will go to the level shifter, come out to them. So you don't need level shifters. You understand? If you're stepping it from 5 to 3 or 3 to 5, you can use these pins. So therefore, if you think that you're going to use any other sensors in the future, you can use that. Okay? So the only drawback of this board is that these tiny sitting drivers, if you can throw them off, and then make it heavy drivers, you can, do heavy duty robots too. Because the controller itself, the brain, the power to go left, right, even on Arduino will do it. Right? To control the motor, it's only going to say go right, go left. The main decision comes from the Raspberry Pi. So this has the small logic to do it. It is interfaceable with Raspberry Pi, which is the higher end of logic. The only thing it lacks is the motor drivers. Okay? Alright, that's okay. So you understand, right? We have to do from the receive to that over there, and then that's how those will connect. Clear? So then you can issue, so what you have to do is issue a command velocity, and then you can see it rotating. Then you're going to change the code such that you will be able to read the accelerometer and the gyro values. You understand? You shake around, and then it's going to actually move it. So before that, you can connect the I2C with the MPU 6050 and get the value. So you have this. So you're going to make multiple, I think 3, I have 4 tasks. Got it? And then install this Raspberry, right? Oh, where is it? Install this and repeat the 3 tasks on that. That's a lot of work from 2 weeks.
Yeah.
No, it's still okay. It's only a few lines of code. But you have 3 brains to work on each project. You can't be one person doing the work. Yeah, when one guy is doing it, the other guy is doing it on Raspberry Pi. Clear? Okay. And then when you want, the other thing you want to do is when you slap the Raspberry Pi, you want to make sure that you're connected to the internet. Okay? So what I will suggest is you use your cell phones, as access points, and just connect it. Because if you're going to work here, probably what I will try to do is I'll try to get an open kind of thing, so that when you are at least here and you guys want to work in the future, I'll just get an access point kind of thing, so you can actually connect it to the net. Okay, as far as you guys name your connections differently. The robot has a different name. Correct? But generally, if you want to work, I would suggest that you work with an access point, or when you work at home, just work with it. You understand? So what I'm saying is, when you slap the Raspberry Pi and you're going to work on it, there's no place to get your HDMI and the keyboard and everything. You're not going to be working directly. So you're going to connect it through SSH. Okay? So maybe try to do it with the Raspberry Pi. In case you don't get it, then we will start next week with the Raspberry Pi. So we basically will start with the Raspberry Pi. Now I have a couple of other things to do. Okay, and then I have to show you some simulations. And I'll show you some simulations. These are simulations. And what you can do is, basically, that's my GitHub. I'll try to update my GitHub, the class GitHub, in this probably by tonight or tomorrow morning. So you guys go and clone it again, and then you run. Okay? So there's a lot of materials here and there and there and here. And then I'll show you some of the things, but I don't think it's really, you're not going to do anything in simulation. You're not going to create your own rover. You're not going to, unless you want to impress somebody, yes. So, but but I can show you some simple things where you can be starting points, and then you can start with them. Okay? And there's a tutorial online. You go to tutorials, and there's a tutorials to build your own rover. Okay? Okay, so let me just tell you a couple of things. So you guys have any questions before I jump into a different topic? So you guys know what to do. Okay, so when we meet on 2 weeks from now, that's 14 days, that's a long time. Okay, so you'll have it done. So what I wanted to show you is, okay. So then we'll do the motor control. There's motor control there. I'll put it up. And as you know, I'm going to work on it too. As you guys work on it, I'm going to work on it too. So I'll probably have to search and find out where my codes are, but it's not really tough. My list is getting bigger. All right. So what I wanted to show you is about simulation. So this has got nothing to do with hardware. Right? So remember, ROS has two purposes: a simulation environment and an environment that controls the hardware. Whatever you're seeing is an environment that controls the hardware. So is both required? Yes. Okay? If you want to really understand robotics, yes. Okay. I think I'm going to kind of clean it up. But okay. So maybe this one is the easiest one. I think I have another one. Okay. So then basically what it is you want to create your own rover, right? So you have like, I don't know, maybe like a